Okay, so the last part, or the part number 6 for the audio notes, is going to be about the additional steps under the solidification and also about the defects related to the casting processes. So we start first with the steps after the solidification. So when your part is going to be solidified, you need to do trimming for the extra parts like uh, the uh, the runners or the gating system or the for example the razor. Also removing of the core, surface cleaning, inspection, repair if required, and heat treatment. So the casting quality is very important. Not all the casting is going to be a successful one. So there are numerous of opportunities for the things to go wrong in the casting operation, resulting in the quality defects in the product. The defect can be classified as follows. First, a general defect, which is common for all the casting processes. I mean the expandable types or the permanent mold. Also, we have some defects related to the sand casting process alone. The general defects are, first, the misrun. The misrun from the name, that means it's missing the opportunity to run all the way till the end of the cavity. So it's a casting that has solidified before completely filling the mold cavity. One of the main reasons for having that is that the metal didn't reach the exact proper pouring temperature. The other one is going to be the cold shot, which is a portion, two portions of the metals will float together, but there is a lack of fusion due to the premature freezing. So the correct casting, these two ends should be meeting and then fused, but they're going to be solidified here, so we're going to have a cavity to create it. Okay, so that's the cold shot. We have the shrinkage cavity, and I think we actually explained this one earlier in the shrinking part. So what's happening here is a depression in the surface or the internal voids caused by the solidification shrinking. Okay, we talked about the solidification shrinkage. And that contain amount of the molten metal available in the last region to be freeze. Okay, so that's closed. We are going to have molten metal here. It's going to be freeze, and this will cause the part to be having the cavities in between. Again, you remember the example that we saw earlier. This one doesn't has a vent. We're going to have the molten metal in the bottom. This start to solidify, shrinking the material, and this will cause the cavity or the shrinkage to occur. We have the cold shots. Okay, a metal splatters during the pouring, and solid bubbles from the foam and becomes entrapped in the casting. So usually this will happen if you're not going to have the good permeability. Gases just strut in and they're going to be solidified and leave it this way. That's why we always going to have the vents to prevent the things, or well, even in the case of the die casting. Now, what are the problems is going to be mainly defects for the sand casting. First one is going to be the sand blows. We're going to have balloon-shaped gas cavity caused by the release of the mold gases during the boring. The other one is going to be the pinholes, which is the formation of many small gas cavities at or slightly below the surface of the casting. We have the penetration, and the penetration of the high fluidity liquid metal into the sand or the mold core, causing the casting surface to consist of a mixture of the sandy grains and metal. Definitely, this can be very easy machined and removed. We have the mold shifting, and this is one of the most annoying problems. A step in the cast products at the parting line caused by the sideways relative to the displacement of the cup and the drag. So for a pot like that, you cannot simply use the pot. You have to simply just recycle it. Now, what are the types of the furnaces for the casting procedure? The furnaces most commonly used in the foundries are going to be the cobalts, the direct fuel fired furnaces, the crucible furnaces, the electrical arc furnaces, and the induction furnaces. Now, how we can select the type of the furnace? Definitely, this will depend on the melting temperature of the metal or the alloy we are using. Okay, so some of them are going to use maybe the gas to do the heating and melting. Some of them require to have the coal, which is going to have a higher internal energy, and some of them just using the electrical arc to do the work, or the induction furnaces. The last two are electrical, so it's going to be a little bit what I call cooler, more friendly, environmental friendly furnaces. Okay, thank you very much, and we're done here. Okay, and we are going to post you the next week slides as soon as we can. Thank you very much for your listening, and see you in the class.